Thank you for your time. We'll be looking at the notes on the law of cosines in these videos to come. So, previously, you learned that if you're given an angle and side, let me write that more neatly, my gosh. If you're given an angle and side combination in a triangle, you can use the law of sines to solve for the remaining components. Today, we'll look at what you can do when you don't have an angle side combo. Okay. This works when we have triangles that are the form side angle side or side side side. Note that side angle side also allows the area computation. Okay. So our law of cosines is this relationship, right? It's essentially an extension of the Pythagorean theorem. Okay. So if I have side a squared, it's going to be given by the sum of the other two sides squared minus double the product of the other two sides times the cosine of the paired angle. All right, so if I have side A with angle A, then I can square the other two pieces. Okay. The isolated side always pairs up with the angle in the formula, right? So if we want to figure out the side length A, we need to be working with angle A. Now, we can manipulate and solve if the equation for the angle if we are simply missing an angle. Okay. No, you should always solve for the obtuse angle first or largest angle first. So if you're given the sides, always find the largest angle first. That's going to be what you need to do. Okay. So let's look at our situation here. Find the measure of angles A, B, and C. If I have a triangle with a side A of 8, so we'll call that alpha for the angle. A side B of 19, we'll call that beta for the angle. And a side C of 14, we'll call that theta for the angle. Okay. So we want to find the measures of these angles. Well, I know my relationship is that 19 squared is going to be equal to 14 squared plus 8 squared minus 2 times 14 times 8 times the cosine of the angle across from 19. Right? So I'm going to go ahead and make these computations. So 19 squared is 361. So 361 is going to be equal to 14 squared plus 8 squared, which is 260. So 260 minus 2 times 14 times 8. So minus 224 cosine of beta. Okay. So if I want to solve for beta, that's going to be 361 minus 260. What? 361 minus 260. So that's 101. So 101 is going to be equal to negative 224 cosine of beta. So therefore, beta is going to be the inverse cosine of 101 divided by negative 224, which is negative 0.451 essentially. So shift cosine, so the arc cosine of that ratio, and I get this number and you're like, wait, why is the pi? What's happening? What's going on? And notice up here I'm in radian mode. So I have to be careful to make sure that I'm in degree mode. So I'm going to go to my home, I'm going to come to my settings, and I'm going to adjust my angle to be in degrees when I'm doing this work for the law of sines and law of cosines. So I adjust to degrees. I can see I'm in degree mode, and I'll come back and make that same computation, right? The ratio of 101 over 224 negative, and that gives me approximately 116.8 degrees. So that's one angle. Okay. I can do the same approach. I can do the same approach if I wanted to find my next angle. And I could say that, hey, 14 squared is going to be equal to 8 squared plus 19 squared minus 2 times 8 times 19 times the cosine of the angle opposite 14, which is theta. And so that means that theta is going to be equal to the inverse cosine of 14 squared minus 8 squared minus 19 squared, right? All that divided by negative 2 times 8 times 19. So the inverse cosine of 0.753, it looks like. And if I do that inverse cosine of that angle, of that answer, that's about 41.12. So I'll say 41.1 degrees. And that leaves me trying to figure out alpha, but I know alpha is going to be based on angles adding up to 180. So 180 minus 116.8 minus 41.1, and that gives me 22.1 degrees. So I have my three angles, right? Angle A is 22.1 degrees. Angle B is 116.8 degrees. And angle C is 41.1 degrees. Okay. Once again, always solve for the obtuse or the largest angle first, if you are given all three sides. Okay. Let's look at our next example. We have a triangle, good form. Always draw out your situation. I have 115 degrees, right? Side B, 15, side C, 10. So I'll call this B, I'll call that A, and I'll call that C. And so notice this is a side angle side. Therefore, I want to use that cosine rule. And what the cosine rule tells me is, let's say that I call that x. I know that x squared is going to be equal to 10 squared plus 15 squared minus 2 times 10 times 15 times the cosine of 115 degrees. So 10 squared plus 15 squared minus 2 times 10 times 15. Oops, not sine, but rather cosine. You want to be careful. Of 115, I know that x squared is going to be 451.8 approximately. So if I take the square root of that answer, and that is approximately 21.3 centimeters. All right, so that's x, which in this is side A. Okay, then how can I do the rest of this work? Well, I can do the rest of this work using the law of sines, or I could do the rest of this work continuing with the law of cosines. It doesn't make too much of a difference. So law of sines would be, let's call that angle beta. I know that the sine of beta all over 15 must be equal to the sine of 115 degrees all over that 21.3 centimeters. Now notice I'm going to keep my full answer. And so I have 15 times the sine of 115 degrees divided by that 21.3, which is the answer. And that gives me that the sine of beta is approximately 0.6396. So I'm going to go inverse sine of that answer, and that gives me that beta is approximately 39.8 degrees. And that means that angle C will have 180 minus 115 minus 39.8. So angle C is going to be 25.2 degrees. So my smallest angle is going to be opposite my shortest side. All right, that if I was to solve this, we said that this was 25.2 degrees, and this was 39.8 degrees, and this length was 21.3 centimeters. Okay, so that is using the law of cosines when you're given just sides, using the law of cosines when you're given a side angle side situation. Remember, be sure that you're in degree mode. On the NumWorks calculator, you can go down to the settings and make sure that the angle is in degrees. Okay. Thank you for your time. We'll look at a few more problems for the notes in the next video.